This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The most important idea is simple. An electrical panel does not occupy only the metal box mounted on the wall. It owns an invisible three-dimensional volume around it. If another trade, a wall, a cabinet, stored material, or even the panel door itself interferes with that volume, the layout can fail even though the panel is securely installed and wired. I want you to picture an invisible phone booth attached to the face of the panel. The worker stands inside that booth to inspect, operate, or service the equipment. The booth has to remain open from the floor upward, and it cannot become a storage alcove after the project is finished. That mental picture is the heart of this lesson because it turns several separate measurements into one field supervision decision. Protect the whole volume, not just the wall space where the box hangs. The first zone is called working space. Working space is the clear area directly in front of the electrical equipment. For the standard residential and light commercial condition covered here, where the nominal voltage is 0 through 150 volts to ground, the baseline depth is 36 inches. The width is not automatically 30 inches in every case. It must be the width of the equipment or 30 inches, whichever is greater. If the panel is 24 inches wide, the clear working width still has to be at least 30 inches. If the equipment is 40 inches wide, the clear width has to be at least 40 inches. The equipment width sets the minimum whenever the equipment is wider than 30 inches. The vertical working space starts at the floor, grade, or platform and continues to 6 1/2 feet, which is 78 inches, or to the height of the equipment, whichever is greater. This is not a head clearance bubble only around the electrician's face. It is a clear vertical zone beginning at the walking surface. I put the baseline dimensions together in one reference table. The memory line is 30 wide, 36 deep, and 78 high, but I want you to remember the qualifications. 30 inches is only the minimum width when the equipment is not wider. 36 inches is the baseline depth for the condition from 0 through 150 volts to ground. 78 inches is the baseline height unless the equipment itself is taller. The fourth field check is the door swing. Equipment doors and hinged panels must be able to open at least 90 degrees. A layout can meet the tape measure dimensions and still fail if a return wall, water heater, cabinet, or mechanical unit blocks that full opening. One of the most common misconceptions is that the panel must sit perfectly centered inside a clear zone that is 30 inches wide. California working space requirements do not require centering. The panel may sit toward one side of the clear width as long as the full required width exists and the equipment door can open at least 90 degrees. Suppose a framer places a panel close to the corner of a utility room. The panel is 20 inches wide. There are 30 inches of clear working width across the front of it. The required depth and height are open, and the door swings fully past 90 degrees. The fact that the panel is not centered does not create the violation. Now change one fact. Suppose the corner return is so close that the door opens only about 60 degrees. The floor area may still look generous, but the installation has a coordination defect because the hinged panel cannot open far enough. The practical lesson is that I do not stop after measuring a rectangle on the floor. I physically swing the door. That door swing check belongs early in the project. Once drywall, trim, cabinets, equipment pads, or mechanical units are installed, a missed conflict becomes expensive. Catching it while layout lines and framing are still adjustable turns a future tear-out into a simple correction. Depth creates a different kind of mistake. For standard equipment at 0 through 150 volts to ground, the working depth is 36 inches regardless of whether the opposing surface is wood, drywall, masonry, or another ordinary building surface. That makes the baseline easy to remember for common residential and light commercial coordination. I do not carry that rule for 36 inches into every higher voltage installation. Above 150 volts to ground, working space depth can increase depending on the condition of the opposing surfaces. Those higher voltage cases require the applicable California table and project-specific verification. For General B supervision, the safe judgment is to recognize when the simple residential baseline no longer controls and to coordinate with the electrical professional and approved documents. The headroom rule is also easy to underestimate because people tend to look only at the panel face. The clear space extends from the floor or platform all the way up to 6½ feet, or higher when the equipment is higher. A shelf at chest height, a low duct, a deep soffit, or stored material can violate that working volume even if the floor directly in front of the panel is empty. This is where the invisible phone booth is useful. Imagine glass walls around the required width and depth, with a glass ceiling at the required height. If a permanent building element or stored item breaks through that glass, I treat it as a conflict that needs to be resolved, not as a harmless use of leftover space. The second zone is dedicated equipment space, and it is not the same thing as working space. Working space protects access for the person in front of the equipment. Dedicated equipment space reserves the equipment's own vertical airspace from foreign building systems. For indoor installations, the dedicated footprint matches the width and depth of the electrical equipment. That footprint extends from the floor to 6 feet above the equipment, or to the structural ceiling when the structural ceiling is lower. Inside that column, piping, ducts, drain lines, steam lines, and other systems foreign to the electrical installation do not belong. I put the two zones side by side because the distinction is easier to retain when the purposes are separated. Working space is the human access zone in front. Dedicated equipment space is the electrical-only column that follows the equipment's width and depth footprint. One keeps the operator's path open. The other keeps competing trades out of the electrical equipment's reserved airspace. A suspended lay-in ceiling does not end the dedicated space because it is not the structural ceiling. If the panel sits below acoustic ceiling tiles, I still look above the tiles. A plumber may see an open route across the room and assume that the ceiling cavity is available. The electrical dedicated zone continues through that suspended ceiling toward the structural deck, subject to the limit of 6 feet above the equipment. Consider a hypothetical project where a plumber routes a waistline straight across the space above a panel because it shortens the run. The electrical panel face is clear, the door opens, and the floor is empty. The installation can still have a coordination problem because the foreign pipe occupies the dedicated equipment space. The correction is not to argue that the front clearance is open. The correction is to reroute the foreign system outside the reserved footprint or follow an approved project-specific solution. The working space must also remain free of storage. This is not a rule that disappears after final inspection. Title 8 treats sufficient access and working space as an ongoing workplace requirement, and California enforcement records document panels blocked by boxes, materials, heavy equipment, plastic containers, fluorescent bulbs, and buckets. That matters to the General B contractor because the layout decisions influence how the owner will use the finished room. If the panel is placed at the back of a narrow supply closet, the drawing may show a technically empty rectangle, but the room's ordinary use may invite shelving and storage directly in front of the equipment. A better coordination decision is to make the required clearance obvious, usable, and difficult to misunderstand. Suppose the owner asks for shelves beside a panel. I do not answer that request by looking only at the shelf depth on paper. I check the required working width, the full baseline depth of 36 inches, the vertical clearance, the 90-degree door swing, and the path into and out of the space. I also look above the equipment for dedicated space conflicts. The review is three-dimensional. This is one reason floor marking can help during construction. Temporary tape or protected layout marks can show the clear working rectangle before other trades fill the room. The marking is not the legal clearance by itself, and it does not replace measurement. It is a coordination tool that makes the invisible space visible while framing, rough plumbing, heating, and air work, and finished installations are still moving. Panel location has its own restrictions beyond the working space measurements. Overcurrent devices are not permitted in bathrooms of dwelling units, dormitory units, or guest rooms and guest suites. Providing ground fault protection does not create an exception for placing the panel in one of those bathrooms. Overcurrent devices also cannot be placed in the vicinity of easily ignitable material, and closed closets are the classic problem. A utility closet or dedicated electrical room is not automatically a closed closet. The distinction is the actual use and the presence of easily ignitable storage, not the word closet on a casual job site label. Panels also cannot be located over the steps of a stairway. A clear rectangle measured in the air does not fix the unstable working position created by stair treads. The field decision is to reject the location during planning rather than trying to justify it after equipment has been installed. These location rules are a good reminder that dimensions are not a substitute for suitability. A space may be large enough and still be prohibited. When I review a panel location, I ask two separate questions. Is this location allowed at all? If it is allowed, does the complete working and dedicated space fit? Large commercial equipment adds egress requirements that affect room layout, doors, and hardware. Equipment containing overcurrent, switching, or control devices that is rated 1,200 amperes or more and is more than 6 feet wide generally requires an entrance to and egress from the working space at each end. The required entrance or egress opening is at least 24 inches wide and 6½ feet high. The code also provides limited conditions that can allow a single entrance, including an unobstructed path away from the equipment or working space depth that is doubled. Those are not shortcuts to assume in the field. They are conditions to verify against the applicable code, approved design, and electrical coordination. The large equipment reference table separates the two thresholds that contractors often blend together. The trigger at 1,200 amperes or more than 6 feet wide relates to entrances at each end of the working space. The threshold at 800 amperes relates to certain personnel doors located within 25 feet of the equipment. When a personnel door is intended for entrance to and egress from the working space and is within 25 feet of equipment rated 800 amperes or more, the door must open in the direction of egress and use listed panic hardware or listed fire exit hardware. The practical effect is straightforward. The worker must be able to move out without stopping to pull a door inward or operate a small conventional latch. Open equipment doors also cannot obstruct entry to or egress from the working space. That means I review the room with the electrical equipment doors in their open position, not only with every cabinet neatly closed. A door that looks harmless on a floor plan can become a barrier when the gear is being serviced. A reliable field supervision sequence starts before the panel is mounted. I first confirm that the proposed location is permitted. I then reserve the working width, depth, and height. I check the full door swing. After that, I reserve the dedicated equipment footprint up to the required vertical limit and coordinate every plumbing, mechanical, fire protection, and architectural route around it. Before walls and ceilings close, I repeat the check with actual installed conditions. I do not rely only on the plan because field routing changes. A pipe may have shifted, a soffit may be deeper, a housekeeping pad may have grown, or a door frame may have moved. The most useful inspection is the one performed while the conflict can still be corrected without demolition. After finishes and equipment are installed, I check the space again. I look for cabinets, shelving, water heaters, carts, stored material, and door swings. At turnover, I make the clearance understandable to the owner or facility staff because the working space must stay clear during the building's use, not only on inspection day. This is the general B boundary. I am teaching spatial coordination, defect recognition, and inspection readiness. I am not teaching conductor sizing, voltage drop calculations, conduit fill, interrupting ratings, or electrical load calculations. Those specialty calculations belong with the qualified electrical trade and the approved project requirements. Here is the memory connection I want you to carry into a plan review or job walk. For the common condition from 0 through 150 volts to ground, think 30, 36, 78. 30 inches of minimum width unless the equipment is wider. 36 inches of depth. 78 inches of height unless the equipment is taller. Then swing the door to 90 degrees. After that, look up. The equipment owns dedicated air rights matching its footprint, extending to 6 feet above the equipment or to the lower structural ceiling. A drop ceiling does not erase those air rights. Finally, ask whether the location itself is permitted and whether storage or another trade will invade the space later. The central distinction is worth saying one last time. Working space is for the person. Dedicated equipment space is for the equipment. If you keep those two purposes separate, the dimensions and trade conflicts become much easier to sort out. I made an audio practice quiz specifically for this episode's electrical panel clearance material. It is audio-based, the questions are read aloud, and you answer by tapping, which is built for people studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the clearances, locations, or coordination decisions I covered. Subscribe so I can help you stay on track through every episode until you get your license. I know you are fitting this study time around real work and real responsibilities, and I want each lesson to make that effort count.